Okay, so let us start with today's chapter. We had finished a few things regarding sampling. Do you remember what is principle of inertia? Who remembers principle of inertia? Please tell me. Tell me what is principle of inertia as well. Yes. Omkar, tell me what is principle of inertia. Read and tell me, that's fine. See, we have done with all the 4 laws: law of statistical regularity, principle of inertia, principle of optimization and validity. Okay. Yes, anyone can read it for me if possible. No answer? Atharva, principle of inertia. हे काय आता? करेक्ट. सो कळलंय ना? आता हे काय आहे? का म्हणजे आता हे? हां, थँक्यू. Okay, so now this we had done, have we done this part? Population, what is population? Yes or no? If you are going to help me, then I will start, otherwise we will sit like this only. Harshavardhan, did we finish this part? Yes or no? Population is done. What is a sample? What is a parameter? These formulas we had written down. Do you remember? Statistics. Okay, let us consider this example now. Have we done this example before? Okay. So a population comprises of the following units: A, B, C, D and E. Draw all possible samples of size 3 without replacement. So with replacement and without replacement, we have seen the formulas up till now. These are the formulas: with replacement, without replacement. So WOR is without replacement, with replacement is WR. Have we done this part? No. So let us go to the, okay, give the heading as sampling distribution and standard error of a statistic. Sampling distribution and standard error of a statistic. So write down population of n units. Population is given of n units. We have to draw a sample of fixed size small n. From the population of n units, we have to draw a sample of fixed size small n. Okay, now there is a what you can say, anybody has done permutation combination in 10th standard? I think CBSE board must have done it. Permutation combination in 10th standard, Harshavardhan? Okay. So now, so after this write down, when it comes to sampling without replacement, when it comes to sampling without replacement of the sampling units, then the total number of samples can be NCN. See this part. then the total number of samples will be NCN. Then write down, if we compute the value of a statistic, say mean. Do you know what is a mean? Mean is average of two numbers. So if we compute the value of a statistic, say mean, so that mean value, will it be the same as the original values? No, but it is going to be somewhat near the original values, okay? So this is called as sampling fluctuation. So write down, if we compute the value of a statistic, say mean, then the value of the sample, mean, then the value of the sample mean may vary from sample to sample. Then the value of the sample mean may vary from sample to sample as the sampling units of one sample may be different from another one. As the sampling unit of one sample may be different from another one. This variation is called as sampling fluctuation. This variation is called as sampling fluctuation. Now this is important. This entire part up till here. If it is possible to obtain the value of a statistic, okay, I'll wait. Please let me know. Harshavardhan, the thing is that when you come to teach here, you just want to tell a lot of things. So you tend to speed up, okay? So as students, please understand this and tell me. अथर्व, सॅम्पलिंग फ्लक्च्युएशन कळलं? मीन काढतो आपण. समजा दोन नंबर्स आहेत, 11 आणि 12. त्याचं मीन काय येणार आहे? 11 + 12 अपॉन 2. सो काहीतरी 11.5 और समथिंग काहीतरी येईल. मग इज इट इक्वल टू 11 का 12? नाही ना, इट इज नॉट इक्वल टू नीदर, पण इट इज नियरर. सो हे झालं फ्लक्च्युएशन. ओरिजिनल व्हॅल्यू होती 11, पण मीन काढल्यानंतरची व्हॅल्यू आली 11.5. ती सेम आहे का? ह्याला म्हणायचं फ्लक्च्युएशन ऑफ मीन. कळलं? झालं? रिटन डाउन दिस पार्ट. Write down this part. If it is possible to obtain the values of a statistic T from all the possible samples of a fixed sample size along with corresponding probabilities, then we can arrange the values of the statistic, which is to be treated as a random variable, in the form of probability distribution. Such a probability distribution is called as sampling. Such a probability distribution is called as sampling. सो आता काय केलं? आपल्याला वेगवेगळे साइजेस मिळाले, ओके, वेगवेगळे सॅम्पल्स मिळाले. सो दे हॅव अ फिक्स सॅम्पल साईज. हां अथर्व, 11 आणि 12 हे 2 सॅम्पल झाले आणि 11.5 हा तिसरा सॅम्पल झाला. म्हणजे प्रत्येक आपल्याला 3 सॅम्पल्स मिळाले 1111 नंबरचे ऑफ द सेम लेंथ. हां आता काय करायचं, वी विल अरेंज दीज व्हॅल्यूज आणि त्याच्यातला कुठलाही एक आपण एक रॅन्डम व्हेरिएबल म्हणून घेणार. सो समजा मी 11.5 हा रॅन्डम व्हेरिएबल घेतला. देन प्रोबॅबिलिटी डिस्ट्रीब्युशन म्हणजे हा रॅन्डम व्हेरिएबल घेतलाय आणि त्याच्याप्रमाणे मी जेव्हा अरेंज करणारे डेटा, दॅट इज कॉल्ड ॲज सॅम्पलिंग डिस्ट्रीब्युशन ऑफ अ स्टॅटिस्टिक. म्हणजे तो आता मी रॅन्डम सॅम्पल धरणार आणि अकॉर्डिंग टू दॅट आय एम गोइंग टू डू द कॅल्क्युलेशन, पुढचे कॅल्क्युलेशन. सो ह्याला म्हणायचं सॅम्पलिंग डिस्ट्रीब्युशन ऑफ अ स्टॅटिस्टिक. Finished writing up till here? Now, okay, I'll wait. Online students, if you have any doubts, please ask. The mean of the statistic, write down after this. Let me know once you finish writing this part. The mean of the statistic obtained, write down. The mean of the statistic obtained from its sampling distribution is known as expectation. See, I have marked it. The mean of the statistic as obtained from its sampling distribution is known as expectation, and the standard deviation is known as standard error, SE. आता I am going to explain all this with respect to an example, don't worry. Just write this down. The mean of a statistic as obtained from its sampling distribution is known as expectation, and the standard deviation of the statistic T is known as standard error. Standard error is inversely proportional to square root of sample size. Okay, written down? Have you written it down? Finished? Now write down SE, standard error is inversely proportional to square root of sample size. Standard error is inversely proportional to square root of sample size. So the formula SE x bar म्हणजे SE of mean is given as sigma upon root n with replacement. This is for with replacement. With replacement. So this is called as SRS with replacement. आत्ता तुम्हाला काही कळणार नाही. I will take an example plus, but please write down these formulas. I am going to explain, don't worry. SE x bar is given as sigma upon square root of n for SRS with replacement. Next write down that is equal to, write down this entire thing, all the examples. all the equations, all this part. SRS is simple random sampling, WR is with replacement, WOR means without replacement. Simple random sampling is SRS. Write down this entire part. SRS is simple random sampling, WR is with replacement, WOR is without replacement. I know right now you will not understand anything, I know it. I can see a question mark on everybody's face, don't worry, I am going to explain with the help of an example. हाँ मल्टीप्लाइड बाय यहाँ पे हाँ दिस इज मल्टीप्लिकेशन, दिस इज मल्टीप्लिकेशन. So standard error for proportion for SRS without replacement is given by the formula square root of PQ upon N multiplied by square root of capital N minus N upon capital N minus 1. So basically this is called as a population, finite population multiplier. This is called as a finite population multiplier. And if it tends to 1, then the sample size is very large. If this factor tends to 1, then the sample size is very large and the population is infinite. And then the population under consideration is infinite. Finish writing, all of you? Finished? Now let us take this example. Pay attention everyone. A population comprises of the following units A, B, C, D and E. So how many units in all? 5. Draw all possible samples of size 3 without replacement. So size 3, what is the meaning of that? Value of small n is equal to 3. Capital N is going to be 5 because 5 units are there. So capital N is 5, small n is 3. Okay. Therefore, total number of possible samples without replacement is, formula क्या था हमारा? Capital N, C, small n. Now, when we talk about C, आता हे कोणाला माहिती नसणार आहे. So I am going to tell you what is the meaning of this. N, C, small n. This means combination, permutation and combination. So how many of you know permutation combination? Please raise your hands. Only 3 of you. All right. Let us say out of 9 students, I have to select any 3 students. Any 3. There is no condition on which type of students are there. Okay. So let's say out of total 9 students, I have to select any 3 students with no condition. Then we are going to apply permutation in that case. What is permutation? NPR, where N is the total number of children, R is the number of children whom I am going to select. Okay. So this is given by the formula. Do you know what is the formula? N factorial upon N minus R factorial. Ata, does anybody know what is a factorial? If I say 2 factorial, what is the value of 2 factorial? 1 multiplied by 2, that is 2. If I say 4 factorial, 1 into 2 into 3 into 4. So the answer is, now here in this case, I am going to arrange it as 9 factorial upon 9 minus 3 factorial, that is 6 factorial. This is permutation. Okay. Now I have to select out of 9 3 children such that all 3 children are girls. Consider this second case. अथर्व 9 स्टुडंट्स पैकी मला 3 स्टुडंट सिलेक्ट करायचे जे गर्ल्स आहेत. आता इथे कंडिशन आहे, मी कोणालाही रॅन्डमली सिलेक्ट करू शकते का? नाही. कंडिशन काय आहे? दोज हॅज टू बी गर्ल्स. In that case, I am going to use combination. So NCR, आपल्या केस मध्ये value of N is 9 and R is 3. So the formula for combination is N factorial upon R factorial into N minus R factorial. Have you understood the difference between permutation and combination? सगळ्यांना कळलंय? Any doubt in this? कळलंय ओम? अथर्व कळलंय? आता, so basically this is the meaning of NCN. Understood? Now let us go to this part. So basically in our case, the value of capital N population is 5 because there are total 5 units. Value of small n is 3. Why? Because they have mentioned that you have to draw all possible samples of size 3 without replacement. So small n is 3. So now according to the formula, we are going to apply it like this. 5C3. What is the formula? 5 factorial upon 3 factorial into 5 minus 3, that is 2 factorial. Now pay attention. How are we going to solve this? First write down this formula. NCR is equal to, write this formula all of you. NCR, okay, just give me a minute. Online students, if you are not able to see, I think now you will be able to see. Okay, NCR is given by the formula N factorial upon R factorial into N minus R factorial. So we are going to solve this. So now this I am going to solve. I am going to write this as 5 into 4 into 3 factorial upon 3 factorial, and what is the value of 2 factorial? So this 3 factorial and 3 factorial will get cut. 5 into 4 is 20. 20 divided by 2, answer is going to be Correct? Please write this down, everyone. Since you do not know the base of permutation combination, I have first explained you what is permutation. When there is no condition and we have to select a certain number of children from the total, then it is a sum of permutation. When there is a condition that the three selected students have to be girls, so in that case we are going to apply combination. So you have understood the difference between permutation and combination. Yes? And the formulas I have also given you. According to the formula, we are going to solve this sum and the answer comes out to be 10. I hope everybody has understood this part. It's a bit complicated, but if you try and understand it, it is not that difficult. Okay? Finish writing, everyone? Okay? So now the answer comes out to be 10. Here they have not shown you how it is done. I have shown you how it is done. Now consider the next example. So basically the possible ways in which you can find out without replacement are ABC, ABD, ABE, ACD, ACE, ADE, BCD. So each and everything is different. There is no repetition. So this is without replacement. We are not going to replace anything. Understood the meaning of with replacement, without replacement? Now consider example 3.22. A population comprises of 3 members. So tell me, what is capital N in this case? 3. Draw all possible samples of size 2. What is the value of small n? First with replacement, second without replacement. Okay. So find the sampling distribution of sample mean in both cases. So now with replacement, what do we do? Small n is 2, capital N is 3. So the total number of possible samples with replacement will be 3 square. Why 3 square? Because this is a formula in case of permutation combination. That chapter we have not done. 2 raised to n, that is the formula. Okay. So here 2 raised to small n. What is the value of? So in this case, see. नहीं लगा यहाँ पे, so because capital N raised to small n का formula लगा, because capital N is total sample and small n is the sample size. So capital N raised to small n का formula is used over here. Have you understood this part? So that comes out to be 3 square, that is equal to 9. So now in this particular table, इथपर्यंत कळलं अथर्व? मी थांबून जाणार आहे कारण I know it is a bit complicated. I understand. So कळलं नाही तर प्लीज आस्क. कळलं इथपर्यंत मी काय काय सांगितलं? परम्युटेशन कॉम्बिनेशनचा डिफरन्स कळला? Now if you see here, so samples of size 2 with replacement. With replacement यानी क्या? The number can come again and again. You can replace it. So here you can see 1, 1, 1, 5, 1, 3. Sample sizes of 2. Okay, so only 2 numbers are selected at a time. So 1, 1, 1, 5, 1, 3 and so on. So if you find out the mean of this, what is the mean of 1 plus 1 upon 2? 1. So x bar is nothing but mean. So similarly they have found out the sample mean for all the options. Now we have to do sampling distribution of sample mean. So see, look here, x bar values are taken. So if you see 1 is repeated how many times? Total are 9. So out of 9 only 1 is repeated. So 1 upon 9 is going to be P, probability. P is probability. What is the formula of probability, which you have already studied in 10th standard, all boards? You remember what is the formula of probability? Denominator में total number and numerator में 1 is repeated how many times? 1 time. possible outcomes upon total number of outcomes. So that is 1 upon 9. Huh? Similarly here 2 is repeated how many times? 2 times. So it is 2 upon 9. 3 is repeated how many times? 1, 2, 3. 3 times. And so on. So have you understood this part, this table? Okay. Write down this. Write down this, and here write down capital N is equal to 3, small n is equal to 2. Capital N is equal to 3, small n is equal to 2. When you do the example, it is more clear to you. Okay, so I am explaining this concept with an example. Online students, if you have any doubts, feel free to ask. Are you able to see everything correctly? Please write in the chat box so that I understand. समजताय का हितेश? येस और नो एवढाच आन्सर हवाय मला. मीन. गुड आन्सर. मॅथमॅटिकली correct. So please write this down. Then I will tell you what they mean by without replacement. So when there is without replacement, formula is capital N, C, small n. Always remember. So first basically you will have to find out the mean. Mean, how do we calculate now here? It is 1 plus 5 upon 2, that is 6 upon 2, it is going to be 3. Okay? So you all of you know how to calculate the mean values. Mean values, you have to add both the values divided by total number of values. Finished writing? So now the sampling distribution table of sample mean is written. Can anybody tell me why is the total equal to 1? Can probability be greater than 1? Is it possible? Probability is always equal to 1. So the total is taken as 1. So whenever you have to do without replacement, straight away use the formula of combination. Capital N, C, small n. So your answer is 3C2, which comes out to be equal to 3. So 3C2 means 3 factorial upon 2 factorial into 1 factorial. Use the formula to solve it. So this is without replacement. They have used the formula. Shall I move ahead? Is it okay? Now, finished? So now see here, answer comes out to be 3. Now what they have done without replacement, WOR scheme. So sample is of size 2, you cannot replace it. So 1, 3, 1, 5 and 3, 5. Find out the mean of these, which comes out to be 2, 3 and 4. Then draw the sampling distribution table of the mean. So I hope you have understood this, what they have done over here. Have you? Without replacement means you cannot have the same numbers again and again. That is the meaning of without replacement. So everybody has understood this. Write down this table. Okay, so have you understood, all of you, have you understood this part? Yes. वापस करूंगी. सो यहाँ तक हमने क्या किया है, यहाँ पे हमने रिप्लेसमेंट विथ रिप्लेसमेंट यानी व्हाट, 1 1 is taken, again they have taken 1, again here they have taken 5,1, so it is repeated again and again. Whereas if you see in without replacement, have they repeated any number? 1 3 is taken, then 1 5 is taken, I agree, but are 3 5 repeated again and again? From this they have found out, see, possible samples of size 2 from a population of 3 units under without replacement scheme. So have they taken the same number again and again? Means 1 5 1 5 5 1, is it repeated again and again? No, they have taken it only once. So as you can see over here, they have taken it only once. 1 3 is taken only once, 1 5 is taken only once. Is 1 3 and 1 5 same? No, it is different. Similarly 3 5 is different. So they have not repeated any numbers. So that is without replacement. Understood? So the sampling distribution is taken, they have solved. So have you understood this particular example, all of you? Any doubts? Let us go to the next part. Compute the standard deviation of sample mean for the last problem. So basically this is the last problem, okay? They have taken this. Let u is equal to x bar. What is the meaning of x bar? Average of x. Average. X bar यानी average. Okay. So u is a sampling distribution function. So 1, 2, 3, 4, 5. Probability is taken as 1 upon 9, 2 upon 9, 3 upon 9, 2 upon 9 and 1 upon 9. The same table is considered as the last example. Now, first you will have to find out E of u. So, what is that? Summation of P into u. Okay, summation of P into u. So, what we are going to do? 1 into 1 by 9 plus 2 into 2 by 9 plus 3 into 3 by 9 plus 4 into 2 by 9 plus 5 into 1 by 9, which comes out to be equal to 3. Then next step, इथपर्यंत कळलं अथर्व काय केलं? P आणि U ची मल्टिप्लिकेशन केली आणि सगळ्यांना ऍड केलं. Next, E of U square. E of U square is given as summation Pi Ui square. Okay. So now here is P, 1 upon 9. What is 1 ka square? 1. So 1 into 1 upon 9 plus what is 2 ka square? 4. 4 into 2 upon 9 plus 3 ka square into 3 upon 9 plus 4 ka square into 2 upon 9 plus 5 ka square into 1 upon 9. This summation they have found out. Have you understood this step? Now V of x bar. V of x bar is taken as V of u, which is nothing but E of u square minus E of u whole bracket square. Understood this step, what they have done? So they have found out the standard error का square which comes out to be 4 upon 3. Therefore, standard error is square root of 4 upon 3, that is 2 upon root 3. हे कळलं सगळ्यांना? What they have done? This is called as standard deviation. So 1 upon 9 into 1 is 1 by 9. Okay. 2 upon 9 into 2 square. So that is 2 cube upon 9, that is 8 upon 9. So this is 1 upon 9, this is 8 upon 9. This becomes 27 upon 9. 3 का cube. 3 into 3 square. नाही, थांब दाखवते. Wait, I'll just write this down. म्हणजे 3 का square into 3 upon 9. So what is that? 3 cube upon 9. So that what is the answer? What is 3 cube? So 27 upon 9 is how much? So all those values are added together. So we have got SE which comes out to be 2 upon root 3. Now they have given us that the population comprises of how many units? 3. Capital N is 3. Okay. So X1 is the first unit, X2 is the second unit and X3 is the third unit. So they have found out mu, which is nothing but the population mean. Okay. Mu is given by the formula summation of XA upon capital N. This we have done in last lecture. If you were mentally present, you will remember. काय? बरोबर ना? हसायला आलं बरोबर अथर्वला. म्यू म्हणजे मीन, पॉप्युलेशन मीन. त्याचं सिम्बॉल आहे. हे जे आहे ना, हे सिम्बॉल दिसतंय सगळ्यांना, दॅट इज कॉल्ड ॲज म्यू. Mu is population mean. That is given by the formula summation of XA upon capital N. आता what was X1? 1. X2 was 5. X3 was 3. So 1 plus 5 plus 3 is how much? 8, 9. So 9 upon 3 is 3. And population variance हे बघ इकडे अथर्व सिग्मा स्क्वेअर याला म्हणायचं सिग्मा स्मॉल सिग्मा. पॉप्युलेशन व्हेरियन्स. आता हे मला माहिती आहे की तुम्हाला व्हॉट इज मीन व्हॉट इज व्हेरियन्स हे काहीच कळत नाहीये आत्ता, विच इज ओके. नेक्स्ट चॅप्टर मध्ये आपण हेच शिकणार आहोत. हाऊ वी आर इन द नेक्स्ट चॅप्टर वी आर गोइंग टू स्टडी हाऊ वी आर गोइंग टू फाइंड आउट population variance and population mean. So don't worry if you don't understand it right now. Okay, I'm going to explain it in the next chapter. Okay. Now population variance ka formula sigma square is given as summation of XA minus mu whole bracket square upon N. So they have used this formula to get the answer which is 8 upon 3. And then we have found out what is SE. SE is sigma upon root N. So now up till here I think everybody has understood. So please write it down so that it will get fixed over here. That is very important. Draw this table. Draw this table U and P. Find out E of U. Please write it down. We are writing down the solved example given in the textbook so that you will understand the formulas very well. बडबड नाही केली तर चालेल. हितेश हे कळलं? हितेश सगळं तुला पक्क? ओम, हर्षवर्धन, हॅव यू अंडरस्टूड? पार्ट आएगा नहीं आएगा बट वी हैव टू स्टडी इट राइट, तो ही वो समझ में आएगा. इफ दे आस्क यू द सेकेंड क्वेश्चन डायरेक्टली विदाउट आस्किंग द फर्स्ट क्वेश्चन, so you should know how are the steps, which steps you have to follow. So that is the reason you have to do the entire problem. Understood? No shortcut in that. We are taking the example given in the textbook only. Please write it down. Today the entire time will go into our basics only. Tomorrow we'll start with the exercise part. Okay, please write it down. If anybody has any doubts, please ask. Online students, if you have any doubt, please ask. Nobody is writing in the chat box. Why? Please write something in the chat box. Have you understood what part we have done today? Those who had maths in 11th and 12th, please, it will be very easy for them. So please, if you have any younger siblings, okay, who have just passed 10th standard and they are going to opt for commerce, tell them to take maths in 11th and 12th standard, then only CA foundation is easier. Okay, please spread this everywhere. I don't know why a lot of classes don't tell this, but this is very, very important. Those who want to appear for CA foundation have to take maths in 11th and 12th. Even though you don't get it in college, you can just do it side by side, because then it will be very helpful to you. Please tell your siblings, your friends about this. Okay, written down up till SE is equal to 2 by root 3. Shall I move ahead? Now use these formulas. Okay, I will wait, no problem. I will wait, please write it down. Please write this part also. Population mean, mu is given by the formula. Also write down population variance, which is given by the formula sigma square. And then find out S of E, that is sigma upon root n. Please write it down. Calculate it. Once you finish this, we will go to without replacement. Sampling distribution with replacement we are doing up till now. Now we will do without replacement. So simple random sampling without replacement. Next part. Finished writing, all of you? Now in case of sampling distribution, V is given as 2, 3, 4 and you have to do it without replacement. So the probability is found out without replacement, which comes out to be 1 by 3, 1 by 3, 1 by 3. So E of x bar is calculated now. Everybody has finished writing? So now this part, see, check. Now here in without replacement, the table is different as we all know. Okay. So 2, 3, 4 is the value of V, sampling distribution, and P is the probability, that comes out to be 1 by 3, 1 by 3, 1 by 3. Again the same thing. E of x bar is calculated. E of x bar is calculated as 1 upon 3 into 2 plus 1 upon 3 into 3 plus 1 upon 3 into 4. Okay. So the answer comes out to be equal to 3. Then V of x bar is variance, that is calculated, that is E of V square minus EV whole bracket square. So I hope everybody understand this difference. E of V square minus EV whole bracket square. So what we are going to do? 1 by 3 into 2 square plus 1 by 3 into 3 square plus 1 by 3 into 4 square minus 3 square, which is nothing but E of x bar. That comes out to be 2 by 3. And SE is nothing given as 2 upon root 3. Now without replacement, what we need to do is we need to use this particular formula. So now what you do, write down this table, give the heading as SRS without replacement, SRS without replacement, WOR, and then write down this particular table, that is V and P, and then write these points down. Write down this calculation please for me. So SEX is given by the formula sigma upon root n into square root of capital N minus small n upon capital N minus 1. Use the formula to find out SE of x. Online students, if you have any doubts, please feel free to ask. Write in the chat box. I would appreciate it if you write in the chat box. Hitesh, I can hear you. I can hear you as well. Chat box बंद है? Is it? अच्छा चैट बॉक्स बंद ही है, इज इट? होस्ट अँड दिसतंय कुठे मला? मीटिंग ग्रुप चॅट आहे की ऑन? एनेबल आहे की इथे? उनको करनी पड़ेगी ना. जाऊ दे. एनीवेज, हाँ, इज दिस डन? एस ऑफ ई एक्स यू हैव फाउंड आउट. इतनी मगजमारी मैं नहीं बोलूंगी उनको, बिकॉज आई डोंट थिंक दे विल डू इट. हाँ, नाउ इट इज टाइप्स ऑफ सैम्पलिंग और ज्यादा theory. Okay, now sampling everybody has understood. Huh? Now we are going to do types of sampling. So you have to write a lot today. No calculation, no calculator, you have to write a lot of things. हाँ, पेन खत्म हुआ ना हितेश? Good. Buy another one. आंसर आया? Shall I move ahead? Now give the heading as types of sampling. Multi-stage systematic. Arey wow. So tomorrow we'll start with exercise. So today after going home, you have to just revise whatever we have done today. Huh? That is important. Then only you will be able to answer me tomorrow. चलो, लिख लो. So now tell me, up till now we have seen what is SRS. Huh? What is SRS? Simple random sampling. Okay. So when each member of the population has an equal chance to belong to the sample, then such sampling scheme is called as simple random sampling. Okay. So this was one type which we have studied. We just have simple random sampling, but you should know all these samplings as well. So first type is probability sampling. Give the heading as probability sampling. Write down probability sampling. In this type of sampling, there is a fixed pre-assigned probability. Write down this part. In probability sampling, there is always a fixed pre-assigned probability for each member of the population to be a part of the sample taken from that population. So as we have already seen, there was a probability attached to each and every unit in the previous example. So that is an example of probability sampling. Okay, a probability is already assigned for each member of the population to be a part of the sample that is taken. Next, give the heading as non-probability sampling. Next, give the heading as non-probability sampling. So as the name suggests, no probability is assigned and no probability is attached to the member of the population, and it is based entirely on judgment of the sampler. So basically in non-probability sampling, no probability is assigned and this is based entirely on the judgment of the sampler. So non-probability sampling is also called as judgment sampling. Non-probability sampling is also called as judgment sampling. It is also called as judgment sampling. Please write it down because that will be asked in MCQs. So what will be mixed sampling? Mixed will be a combination of both. Probability, sometimes probability will be assigned, sometimes no probability will be assigned. Okay, mixed sampling is mixture of both. Now, the example of probability sampling is simple random sampling. Example of probability simple random sampling. क्या हुआ? Mixed sampling is a combination of probability and non-probability. Okay, now SRS, simple random sampling. उसमें parts है stratified, multi-stage, systematic. I think instead of writing this and judgment sampling. Okay, we will read this now. Don't write it. Just understand because that is what is important. Banda luggage notebook. Welcome, welcome. Okay, now simple random sampling. But see, I am giving you some time to read the first paragraph. Okay, everyone, please read the first paragraph. Then we are going to discuss. So you have to answer. Manatल्या manat. Nahi. You have to answer. So please read the first paragraph, everyone. When the units are selected independent of each other in such a... Okay, read it. I will give you the examples. समझ में आया? can we say that lottery is an example, a classic example of simple random sampling? Lottery system में क्या होता है? समझ में आया? हाँ, so in that case what you need to do is, that is an example of simple random sampling, because randomly anyone will be selected who will get the lottery. Similarly, let us say there are 25 students in a class. Okay, we have to create sample of 5 students each. So basically what we are going to do, we are going to put slips, name slips, and draw out any 5 names at random. Okay, so each student will have an equal probability of getting selected. Understood the example of SRS, simple random sampling? Now, if you see over here, if however, once the units selected from the population, one by one, are never returned to the population before drawing the next drawing, then sampling is known as sampling without replacement. Means kya? If I select 5, 5, 5, 5 out of 25, okay, my sample size is 5, so how many groups will be formed? 5. Now, these groups will remain as it is. I am not going to replace them. But if somebody says, Hitesh says that he is not comfortable with the 5 which are selected. So what I will do? I will again do the sampling, but now this time I will return Hitesh back to the original group. Okay, or rather return all of you back to the original group, and then again form 5 groups of different people. So when I am doing this, I am doing sampling without replacement. Understood? Correct. I am not replacing anyone. Okay. So this is called as sampling without replacement. So 2 sampling methods. Okay, write these down. The 2 sampling methods become almost identical if the population is infinite. That is, for a very large population, this process is very lengthy, time consuming, as well as money consuming. So whenever the sample size is small, then only you will select simple random sampling. For large population, is this easier? No, because if somebody says that I don't want to be a part of this particular sample, then again I have to do the sampling. Then it becomes tedious. So simple random sampling, so this is the best method of drawing simple random sample, that is to use random sampling numbers. Okay. Now, they have given us the advantages of this. Simple random sampling is very simple and effective method of drawing samples, provided population is not large. Second, sample size is not too small. It should be of some size. It should not be very small. A sample will never be of 1 or 2 people. No. At least 5 and more. अथर्व समजलं? परत मराठीत सांगू? समजा टोटल 25 मुलं आहेत. 25 मुलांपैकी मी 5 मुलांचे ग्रुप्स केले. पण आता हितेश सारखा मुलगा कोणाचंच ऐकत नाही. ओके, तो काय म्हणणार? नाही, आय डोंट वॉन्ट टू बी अ पार्ट ऑफ दिस ग्रुप. मला या ग्रुपमध्ये नाही राहायचं. मग मी काय करणार? सगळ्यांना रिटर्न करणार टू द ओरिजिनल ग्रुप ऑफ 25 पीपल, आणि मग वेगळे 25 पीपल 5 लोक घेऊन मी वेगवेगळे ग्रुप्स क्रिएट करणार. मग आता समजा हितेश तुमच्या तिघांच्या ग्रुपमध्ये आला, तर नाव इज हॅपी असं समजूया. सो दिस टाइप ऑफ सॅम्पलिंग इज कॉल्ड ॲज सिंपल रॅन्डम सॅम्पलिंग. इथे साईज काय आहे सॅम्पलचा? 5 स्टुडंट्स आहेत. टोटल नंबर ऑफ म्हणजे कॅपिटल एन इज हाऊ मच? 25. सो सिंपल रॅन्डम सॅम्पलिंग कधी इफेक्टिव्ह होतं? जेव्हा पॉप्युलेशन साईज खूप मोठा नसेल, छोट्या ग्रुपसाठी इफेक्टिव्ह आहे. ओके, द सॅम्पल साईज शुड नॉट बी स्मॉल. म्हणजे एकटा हितेश मी एका ग्रुपमध्ये ठेवू शकत नाही. दॅट इज नॉट अलाउड. आणि द पॉप्युलेशन अंडर कन्सिडरेशन इज नॉट हिट्रोजनस. म्हणजे हिअर हा जो 25 लोकांचा ग्रुप आहे, ऑल ऑफ यू आर स्टुडंट्स. सो देर इज अ होमोजिनिटी बिटवीन यू, म्हणजे कॉमन फॅक्टर्स बिटवीन यू. Harshavardhan, have you understood? So when we talk about heterogeneous, that means different एज ग्रुप्स के पीपल. ओके, ऑल ऑफ यू आर राइट नाउ स्टडिंग फॉर CA फाउंडेशन. बट इफ देर इज अ मिक्स ऑफ स्टुडंट्स, CA इंटरची मुलं आहेत, CA फायनलची मुलं आहेत आणि CA फाउंडेशनची मुलं आहेत. ओके, सो अशी हिट्रोजिनिटी नाही असायला पाहिजे. जो ग्रुप मिक्स नाही असायला पाहिजे. त्या 25 सगळी जी मुलं आहेत ती सगळी CA फाउंडेशनचीच पाहिजे किंवा सगळी इंटरमिजिएटचीच पाहिजे. मिक्स चालणार नाही. ओके, सो सिंपल रॅन्डम सॅम्पलिंग इज कम्प्लिटली फ्री फ्रॉम सॅम्पल बायस. सो बायस काय असू शकत नाही, कारण हितेश म्हणला मला या ग्रुपमध्ये राहायचं नाही, मी ग्रुप क्रिएट केला, पण तो जो ग्रुप मी क्रिएट केला तो कुठल्या बायसनी नाही. मी सिंपल रॅन्डम कोणालाही सिलेक्ट केलं, एनी 5 स्टुडंट्स. मी असा बायस ठेवला नाही की फक्त द स्टुडंट्स हु हॅव स्कोर्ड मोर दॅन 90 शुड बी इन वन ग्रुप. असं माझा बायस नाही आहे. कळलं बायसचा अर्थ कळला? ओके, नाव Harshavardhan is also saying yes, which is a good thing. Harshavardhan, you are understanding Marathi a bit? No, you are not, it's fine. Okay, now stratified sampling. So up till here everybody has understood simple random sampling. What was the joke? Nothing? Okay, stratified sampling. I think you should write this down. No? You don't want to? Okay. So let us read stratified sampling also. See, right now I am allowing you to read everything, but tomorrow, असे mute वर जर सगळे बसणार असाल ना, तर I don't want that. You have to understand, read the chapter again and come for tomorrow's session, because tomorrow we are going to start with exercises. पक्का. कोणी असं मंदासारखं बसलं की I am not going to continue. काय अथर्व कळलं? ओके, आता नाही, पण अथर्वानी हे खूप चांगलं काम केलं, त्याच्यामुळे ज्यांना कळत नाहीये त्यांना पण आता कळेल. ओके, सो आय लाईक इट. ओके, आता स्ट्रॅटिफाईड सॅम्पलिंग. इफ द पॉप्युलेशन इज लार्ज अँड हिट्रोजिनस, then we consider a somewhat complicated sampling design known as stratified sampling, which comprises dividing the population in a number of strata or subpopulations in such a way that there is very little variation among the units comprising a stratum, and maximum variation should occur among the different strata. Okay, 25 मुलं, group of 25 students. Out of that I am going to create a sample size of 5 students each, but I am going to make 4 such strata. First strata is group. Okay, so first strata will comprise of children who are in blue house. Second strata, houses. Okay, second strata will be of children who are in red house. Third strata of children who are in green house, and then yellow house. Okay, so 1 2 3 4 strata are done. Now each and every stratum is different. The children who belong to blue house, they are different. Children belonging to yellow house are different, green house are different, red house are different. So there is no commonality, common feature between them. Nothing common. They all belong to different houses. Okay, and population is also very large. So now I am not going to take example of 25 students. Maybe I will take an example of 1000 students. A big population. I am converting them into 4 strata, dividing them into 4 strata, blue, green, red, yellow. Okay, there is no common feature. Only common feature is they are students. That's it. So, the stratified sample consists of number of subsamples, one from each stratum. So, different sampling scheme may be applied to different strata. So, समजा red house, if I consider, रेड हाऊसला मी एक डिफरंट सॅम्पलिंग प्रोसिजर केलं की इन रेड हाऊस देर विल बी चिल्ड्रन who will be boys also, girls also, but they all will play badminton. Red house people are the people who play badminton. Okay, so that is their common. So for them I can use SRS differently. For blue house children I will use SRS without replacement. For yellow house, so basically the different stratas I will use different types of sampling techniques. Understood? That is stratified sampling. Why stratified? Because we are forming strata, different stratas. stratum, what we can say. Understood this part? So now, the purpose of stratified sampling are to make representation for all the subpopulations, to provide an estimate of parameter not only for all strata, but also the overall estimate, and reduction of variability and thereby an increase in the precision. So why we are doing this? To get a precise sampling. No error should be there. Understood? परत एक्सप्लेन करू. हां, 1000 मुलं आहेत, 1000 मुलांमध्ये 4 ग्रुप्स मी क्रिएट करतेय. हां, आणि पहिल्या ग्रुपला नाव दिलं रेड हाऊस, ब्लू हाऊस, ग्रीन हाऊस, येलो हाऊस. सो आता रेड वाले लोक फक्त टेबल टेनिस खेळणारे आहेत, ब्लू वाले लोक फक्त बॅडमिंटन खेळणारे आहेत. सो त्यांच्यामध्ये काय कॉमनॅलिटी आहे, डिपेंडिंग अपॉन दॅट मी तो स्ट्रेटा बनवला, 4 स्ट्रेटा. हां, आणि आता ब्लू हाऊसला मी वेगळं सॅम्पलिंग टेक्निक वापरली, SRS वापरली, सिम्पल रँडम. मग रेड हाऊसला मी स्ट्रॅटिफाईड सॅम्पलिंग, की रेड हाऊसमध्ये अशी पण लोक आहेत, लेट्स से जे टेबल टेनिस पण खेळतात आणि बॅडमिंटन पण खेळतात. ओके, so in that case I am going to again use stratified sampling. Again that particular group I am going to divide it into 2 parts. One who play table tennis, other who play badminton. समजलं? सो याला म्हणायचं स्ट्रॅटिफाईड सॅम्पलिंग. आणि नेक्स्ट आहे, सो यू हॅव अंडरस्टूड व्हॉट इज द पर्पज ऑफ स्ट्रॅटिफाईड सॅम्पलिंग. एव्हरीवन, एनी डाऊट? नेक्स्ट, there are 2 types of allocation of sample. Now how will we allocate the sample size? When there is a prior information that there is not much variation between the strata variances, then proportional allocation is done, or Bowley's allocation, where the sample sizes for different strata are taken as proportional to the population size. Now if I say the population size is, say, 1 lakh, I have to create 4 strata. So how many people will be there in one strata? 25,000, 25,000, 25,000, 25,000, 25,000. Now I am going to do this proportional allocation. I am going to make all the sample sizes of equal size. असं नाही आहे की एक साइज मी 10,000चा घेतला, दुसरा साइज मी 25,000 घेतला, तिसरा स्ट्रेटा मी 30,000 घेतला, असं नाही. I have divided all of them proportionally. So that is Bowley's proportional allocation. And when the strata variances differ, then we name it as Neyman's allocation, where sample size vary jointly with population size and there is a deviation. म्हणजे Bowley's allocation म्हणजे काय? Proportional allocation, proportional मध्ये करायचं. Neyman's allocation म्हणजे काय? मी आता population size is how much? 1 lakh. So what I can do? First I can divide it into 2 parts. Males, females. 50,000, 50,000. But not necessarily 50,000 will be females. Females can be less. They can be just 25,000 out of 1 lakh. So now is this type of sampling correct? No, because it is not proportional. So this type of sampling is called as Neyman's allocation, in which depending upon the population I am taking a decision that less number of females are there, so the strata will be of different size. So here n denotes the sample size of ith stratum and so on. So basically stratified sampling is not advisable if the population is not large and some prior information is not available. कारण information मी घेतली आहे, I have taken information from all of you that who love table tennis, who love badminton, who love basketball, and based on this information I am doing the sampling. So some prior information is there, then only stratified sampling is possible. Okay, there is not much heterogeneity among the units of, there is no heterogeneity, right? All of you, all the entire population of 1 lakh, let's say, they are belonging to Maharashtra. So basically there is no heterogeneity in that homogeneous population. Next is the multi-stage. I hope I have explained this clearly. Any doubts, anyone? Now let us go to multi-stage. So as the name suggests, there are going to be 3-4 stages in that. In this type, so basically as the name suggests, multi-stage sampling means what? It is a complicated sampling. The population is supposed to compose of first stage sampling units, each in turn. Okay, so let me give you an example for this. Let's say elections are there, okay, and total 1 lakh people are there. But for elections, the important information should be that all should be citizens of India. Then only they will be able to vote. So my first stage of sampling will be what? From the entire population, I will find out the people who are citizens of India. That is my first stage sampling. Second stage sampling, then I will allow those people to do the voting part. And from those people, let's say 50,000 are females, 50,000 are males. Then I can apply different sampling techniques. So multi-stage sampling म्हणजे काय की मी वेगवेगळ्या स्टेजेसमध्ये घेतलं. मी एक्झाम्पल दिलं इलेक्शन्सचं. इलेक्शनला वोट करण्यासाठी व्हॉट इज द क्रायटेरिया? यू हॅव टू बी अ सिटिझन ऑफ इंडिया. तुम्ही इंडियन्स असाल तर त्या फर्स्ट लेवल ऑफ सॅम्पलिंगला मी हे सगळे फाइंड आउट करणार कोण इंडियाचे सिटिझन्स आहेत. म्हणजे नागरिक आहेत, भारताचे नागरिक कोण आहेत. दॅट इज फर्स्ट लेवल. आणि सेकंड लेवल ऑफ सॅम्पलिंग म्हणजे काय? आता हे नागरिक मला मिळाले. सपोज दे आर 1 lakh. ओके, सो फ्रॉम 1 lakh नागरिक 50 आर मेल्स, 50 आर फिमेल्स. सो नाउ आई विल अगेन use stratified sampling at stage 2. Then again third level sampling, fourth level sampling and so on. आलं लक्षात? याला म्हणायचं मल्टी स्टेज सॅम्पलिंग. So now the coverage in case of multi-stage sampling is quite large, म्हणजे larger than stratified sampling. Okay, and it also saves the computational labor and it is more cost effective. कारण प्रत्येक लेवलला you are doing some work, correct? So प्रत्येक लेवलला you are getting some result. So this is more result oriented sampling. Then next comes systematic sampling. So now see, this is a very important statement. Compared to stratified sampling, multi-stage sampling is likely to be less accurate. Why? Stratify, what we do? We form strata. And at that level only we are going to do everything. But now in multi-stage, what happens? Chala, I have selected the people who are citizens of India, but some of the citizens may be NRI. So that in that case, it is going to be less accurate. Because if I am not going to make that strata different, NRI and Indian citizens, then it will form a problem. There will be error. Understood? So that's why multi-stage is likely to be less accurate. Now let us go to systematic sampling and judgment sampling, and then we will stop for today. Please. Systematic sampling, it refers to a sampling scheme whether you, please read it. All of you, please read it. Otherwise, I am not going to explain. No point in explaining. Those people who are online, I hope you are understanding. Okay, just write down this systematic sampling. I am just going to tell you the steps, how it is done. Write it down. Systematic sampling. Take an example. Write down systematic sampling. If a researcher wants to sample 200 customers, no, it is not given, I am dictating. Okay. If a researcher wants to sample 200 customers from a list of 1000, If a researcher wants to sample 200 customers from a list of 1000, they might select, if a researcher wants to sample 200 customers from a list of 1000, they might select every fifth customer, after randomly choosing a starting point. After randomly choosing a starting point between 1 to 5. I'll repeat. If a researcher wants to sample 200 customers from a list of 1000, they might select every fifth customer after randomly choosing a starting point between 1 and 5. Okay, so let us write down the steps now. Steps: first, define the population size and sample size. Write down first step, define population and sample size. Define population and sample size. First step. Okay. Define population and sample size. So now what will be our N? 10,000. No, in our case 1,000. And what is the value of small n? So sample size is defined as 200. Next step, calculate the sampling interval K. Calculate the sampling interval K. म्हणजे काय? How will you calculate? Divide total population by sample size. Divide total population by sample size. Second, calculate the sampling interval K. Divide the total population by sample size. So write this down. Divide the total population by sample size. Write this down. So this means you will select every 10th student. Calculate the sampling interval, divide the total population by desired sample size. So this means that you will select every 10th student. Third, choose a random starting point. I am telling you the steps. Third, choose a random starting point. Choose a random starting point. So let's say if I pick up number 7. Fourth, third written, choose a random starting point. So I have picked up 7. Fourth, select the sample. Select the sample. So that is the 7th student which I have selected. So 7 plus 10 in our case. Fourth will be select the sample. No, choose a random starting point, that is going to be 7 in our case. Now fourth, select the sample. So select the sample. So what I will do, we are selecting 10, group of 10, 10, 10, 10. Every 10 student we are selecting. So 10 plus 7 is how much? So basically I will first select the 7th one, then I will select the 17th one, then I will select the 27th one, then I will select the 37th one, and so on. कळलं? अच्छा, 10 upon 2 is 5. Okay, my bad. So write 5 over here. So now if this is wrong, then the next step is also wrong. What is wrong in that? Tell me. fifth, every fifth. So if I choose, can I choose 7 now? Can I choose number 7? Yes, I can. Why not? See, even though k is equal to 5, I can choose any number. So if I select 7, so now still it will be 5 plus 7, that is 12. So here it will be 5. So here it will be 12. So after 12, who am I going to select after 12? 12 के बाद 22. 22 के बाद no, not 22 now. It is 5. So 12 plus 5 is 17. 17 plus 5 and so on. समझ में आया? This is called as which sampling? Systematic. चला नहीं, थांबा. Systematic sampling is a convenient method of sampling when a complete and updated sampling frame is available. It is less time consuming, less expensive and simple as compared to other samplings. आणि आता last, purposive or judgment sampling. So start being judgmental now. In judgment sampling, start being judgmental. So in wait, don't close. Judgment sampling, this type of sampling is dependent solely on the discretion of the sampler, and he applies his own judgment based on his belief, prejudice, whims and interest to select the sample. This type of sampling is non-probabilistic, it is purely subjective and it varies from person to person. Of course, correct? No statistical hypothesis can be tested on the basis of this. I don't know why this sampling is included, but they do take it. So understood? So depending upon judgment. कळलं अथर्व? माझं जजमेंट आहे की मला फक्त मुलांनाच सिलेक्ट करायचं आहे. So that is my judgment sampling. Based on that I will select. Here we come to an end of this particular part. So tomorrow we are going to do exercise. Please read everything and come. You are going to answer, not me. Okay, Arnav? All right. So bye-bye. I hope online students also don't have any doubts.